Good morning, everyone. I miss you so much. I hope you are all doing well. Today we will continue explaining Lesson 2, Chapter 2, Changes of States. So please open your books to page 49. First, we will correct the homework. We will understand what melting and freezing are, what the melting point and freezing point are, and we will solve some extra exercises. Let's start by correcting the homework. Please make sure to copy the questions and the answers on your copybook. So the first question, explain how the temperature of a gas is related to the pressure exerted by it. So we previously said that when the temperature of a gas increases, its pressure will increase. And if the temperature of the gas decreases, then its pressure will also decrease. Question 2. Explain why sometimes when you pump air into a balloon, it pops. So when you are pumping air into the balloon, it means you are increasing the number of gas particles in this balloon. And when you increase the number of gas particles, it means that the pressure inside the balloon will increase, and this is why it might pop. Now let's start explaining changes of states. In the picture in front of you, you can see a solid, which is the ice, and you can see a liquid, which is the liquid water. The changes of states between these two, for example, when we go from solid to liquid, we call it melting, and when we go from liquid to solid, we call it freezing. One thing you should really understand is that when the ice melts into a liquid, water, it means that the ice is gaining energy, okay? It's absorbing the heat in order to melt. However, when the liquid transforms into a solid, it means it's becoming cold, so it's losing its energy. So freezing releases energy. We previously learned that the particles in a solid are very close to each other. However, the particles in a liquid are not so close. So during melting, when a solid transforms into a liquid, the particles will gain energy and move apart to form a liquid. However, during freezing, when the liquid loses energy or releases energy, the particles will move closer in order to form a solid. We said that a solid can melt into a liquid. So the melting point, it's the temperature above which this solid can melt. So if the solid does not reach this temperature or higher, it will stay a solid. It cannot become a liquid. We also said that a liquid can freeze into a solid. The freezing point is the temperature below which a liquid starts to freeze. So for the liquid to transform into a solid, the temperature needs to be lower than the freezing point. You can never find two different substances with the same melting and freezing points. Which means, for example, if I talk about water, water has melting and freezing points different than, for example, copper or aluminum. So different substances have different melting and freezing points. For a given substance, the melting and freezing points are equal. If I take water as an example, the melting point of water is 0. But its freezing point is also 0 because these two temperatures are equal. The only difference is that above these temperatures, the water will be a liquid, and below these temperatures, the water will be solid. Let's solve the exercises on your books. Page 49, figure 1. The question is to compare the arrangement of particles between a solid and a liquid. So the particles in ice, which is the solid, have a fixed arrangement. However, in a liquid, which is the water, they are free to move. Page 51a. The change in state from solid to liquid is called melting. Part B. How does what happens to the particles in a substance during melting differ from what happens in freezing? So we have to describe what happens to the particles during melting and freezing. During freezing, the particles move closer because they are losing energy, whereas during melting, the particles move away from each other because they are absorbing or gaining energy. Now let's solve an extra exercise about what we learned. Please copy the questions and answers on your copybook. Copper melts at 1085 degrees Celsius. Specify if you can find another substance that melts at this temperature. The answer is no, because we said that different substances have different melting and freezing points, which means that only copper can have this melting point. Part B, specify the freezing point of copper. We said that the melting point is equal to the freezing point, which means that the freezing point is equal to 1085 degrees Celsius. Part C. Specify the state of copper when the surrounding temperature is 20, 1084, 1096, and 1100 degrees Celsius. To do so, we have to draw a figure that will help us decide. On the figure, we place the melting point in the middle, and below it, or on the left, we have a solid, and after it, on the right, we will have a liquid. Because we said if the temperature is higher than the melting point, then it's a liquid. If it's lower, then it's a solid. After drawing the picture, we compare the temperatures that we have to this picture. For example, the first one, 20 degrees, is less than 1085, so I place it on the left, which means that it will be a solid. 1084 is less than 1085, so also I place it on the left, which means that it's a solid. 1096 is greater than 1085, so I should place it on the right, which means it's a liquid. 1100 is also greater than 1085, so it should be on the right, and it's a liquid. Now, as homework, I need you to copy this exercise on your copybook and try to solve it.